Topic of my presentation is power semiconductor devices. I will introduce them summarily in this session. Main content of my presentation are: Introduction to power semiconductor devices, types of power semiconductor devices, power diodes, Thyristors, SCR, GTO, MCT, MOSFETs, IGBTs. Characteristics of power semiconductor devices. Applications of power semiconductor devices. Let us start with introduction of power semiconductor devices. These devices are semiconductor devices that can handle large amounts of electrical power. They are used as switches or rectifiers in power electronics, such as power supplies, motor drives, and solar inverters. They can handle higher voltages and currents than regular semiconductors and are made from materials such as silicon, silicon carbide, or gallium nitride. Power semiconductors are also known as power devices or power ICs. Some common power semiconductor devices include power MOSFET, power diode, Thyristor, IGBT, BJT, SCR, GTO, MCT. Power diodes and power MOSFET operate on similar principles to their low-power counterparts but are able to carry a larger amount of current and are typically able to withstand a larger reverse bias voltage in the off state. Power diodes are semiconductor devices that have two terminals, anode and cathode, and conduct current in one direction. They are designed to handle large amounts of current and voltage in power electronic circuits, such as rectification, switching, and energy conversion. They have a large p-n junction area to tolerate high forward current and reverse voltage. They act as switches and have negligible power loss when forward biased but must block high voltage when reverse biased. Thyristors are semiconductor devices that act as switches and are used in power electronic circuits. They have 3 or more terminals and can handle large amounts of current and voltage. Some common types of thyristors include silicon-controlled rectifier, SCR, gate turn-off thyristor, GTO, MOS-controlled thyristor, MCT. A silicon-controlled rectifier, SCR, is a 4-layer solid-state current-controlling device. It is a type of thyristor and is used for power control and switching applications. The principle of 4-layer p-n switching was developed by Moll, Tannenbaum, Godley, and Holon Yakov Bell Laboratories in 1956. The SCR was developed by a team of power engineers led by Gordon Hall and commercialized by Frank W. Bill Guttwiller in 1957. An SCR is essentially a Shockley diode with an extra terminal added called the gate. It is used to trigger the device into conduction, latch it, by the application of a small voltage. A GTO is a special type of thyristor. It is a high-power semiconductor device. GTOs are fully controllable switches which can be turned on and off by their gate lead. A GTO can be turned on by the application of a positive gate pulse at the terminal as well as can be turned off when a negative gate current is applied at its terminal. A MOS-controlled thyristor, MCT, is a type of power semiconductor device. It has the ability to transfer current and thyristor voltage through a MOS gate used for switching on and off. MCT was developed by VAK Temple in 1984. MOSFET stands for metal oxide semiconductor field effect transistor. It is a type of transistor with many applications in modern power electronics. Its functioning is based on how electricity flows through it. MOSFETs are electronic devices used to switch or amplify voltages in circuits. IGBT stands for insulated gate bipolar transistor. It is a three-terminal power semiconductor device primarily forming an electronic switch. It was developed to combine high efficiency with fast switching. It consists of 4 alternating layers, P-then, that are controlled by a metal oxide semiconductor, MOS, gate structure. Some of the ideal characteristics of semiconductor devices include passing current more easily in one direction than the other, showing variable resistance, having sensitivity to light or heat, acting like insulators at 0 Kelvin, being smaller in size and possessing less weight than other materials, having higher resistivity than conductors but lesser than insulators, having lesser power losses. Here are some static characteristics shown in figures to understand them deeply. Power semiconductor devices are used in various applications such as switch mode power supplies, variable frequency drives, VFDs, uninterruptible power supply systems, UPS, electric cars, trains, variable speed refrigerators, lamp ballasts, arc welding machines, induction hobs, air conditioners. Thanks for watching. That's all for today's video on introduction of power semiconductor devices. I hope you found it useful and interesting. I welcome your suggestions in comment box on what topic you want me to cover. Keep watching my next videos to understand principles of power electronics. Please subscribe my channel and click the bell icon to get notified whenever I upload a new video. Never forget to like and share.